This CAIE A-Level Maths, Summer 2020, Paper 1, Variant 1, question number 7. In this question, we have to prove this identity, which is identical to 2 upon cos theta. So if we look at this part of the equation, we can the plan that we can have is that we can take the common multiples and then cross multiply these together. So this will be cos theta into 1 plus sine theta, and we can cross multiply this as 1 plus sine theta to the whole square plus cos squared theta. Now if we look at the equation that we have, we can see that we have cos theta in the denominator, which we have in the question as well, and we can also see that we have 1 plus sine theta over here and 1 plus sine theta over here, which are identical. So we need to find a way to cancel these out. So the remaining term that we have is cos square theta, and let's just try to play along with it. So we can use the identity we have, which is sine square theta plus cos square theta equals to 1. We can use this to open up this cos square theta. So we'll have 1 plus sine theta to the whole square plus 1 minus sine square theta upon cos theta into 1 plus sine theta. Now if we look at this, we can say that we have 1 square minus sine square can also be a quadratic identity. So solving this further will give us 1 plus sine theta to the whole square plus 1 minus sine theta 1 plus sine theta upon cos theta into 1 plus sine theta. Now we can see that 1 plus sine theta and 1 plus sine theta are on both sides of the term, so we can just take it out as a common factor. This will give us 1 plus sine theta, and this will leave us with 1 plus sine theta, which is from this term, and the other term will give us plus 1 minus sine theta. This will be upon cos theta 1 plus sine theta. Now we can see that we have 1 plus sine theta and 1 plus sine theta separated, so we can just cancel these two out together. We can also see that we have sine theta over here and we have negative sine theta over here, which can also be cancelled out. This will leave us with 1 plus 1, which will be equals to 2 upon cos theta, solving our identity. In the second part of the question, we have to solve this equation, which is equals to 3 upon sine theta. Since we just proved this 2 upon cos theta, we can write this over here. This will give us 2 upon cos theta, which will be equals to 3 upon sine theta. Cross multiplying will give us 2 sine theta equals to 3 cos theta. Solving this further will give us sine theta upon cos theta equals to 3 upon 2, or tan theta equals to 3 upon 2, and the alpha value for this will be 0.9827. Now if we draw a graph, we know that tan is a positive value, so it must lie in the first quadrant and the third quadrant. So we can just draw a graph, and we know that the alpha value will lie over here and the alpha value will lie over here. So our theta values will be 0.9827 or pi plus 0.9827, giving a final answer theta equals to 0.98 or 4.12.